Once upon a time, deep in the realm of numbers, there was this grand sleight of hand that baffled pretty much everyone who crossed its path. Welcome to our explainer. Today, we're uncovering the mechanics behind one of the greatest illusions in all of mathematics. It's a trick hiding right in plain sight, making numbers behave in ways that, frankly, seem to completely defy logic. Now don't worry, there are no actual spells or sorcery here. It's just pure, brilliant sleight of hand using decimal division. By the end of our journey today, you're going to see exactly how the illusionist pulls off the trick, and better yet, you'll hold the power to see right through it.
So here's the central riddle we need to solve. Think about our basic instincts with math, right? Normally, in our everyday experience, division is all about chopping things up. You divide a pie, the slices get smaller. You divide a treasure chest of gold coins, everyone gets a smaller share. But get ready for this. How on earth does dividing 125 by 0.5 suddenly make the number balloon up to 250? It feels totally backwards, like the number just materialized out of thin air. And honestly, this strange phenomenon is exactly what trips so many travelers up when they first wander into this part of the realm. Just look at the normal world for a second. 120 divided by 5 equals 24. The starting number shrinks. That makes perfect sense to us, right? But then we look at the illusion. 125 divided by 0.5 equals 250. It's kind of intimidating. When that second number, the dividing number, is a decimal, our whole intuition just falls apart. The structural logic we expect gets completely flipped on its head. But like any good illusion, there's a mechanical secret holding it all together.
Section 1. Unveiling the fraction mirror.
Okay, to break this illusion, we need a special tool. We're going to take this confusing decimal and look at it from a totally different angle. The mechanics here are surprisingly simple when you break them down. Step 1, we spot the trickster, that 0.5. Step 2, we hold it up to the mirror. Ask yourself, what is 0.5 really? Well, it's exactly the same as the fraction 1/2, or 5/10. And then step 3, we just rewrite the riddle using those familiar fractions. Suddenly, we aren't wrestling with a floating decimal point anymore. We're dealing with the solid, reliable math we already know.
So the crucial takeaway here is this. Dividing by a fraction like 1/2 is mechanically identical to multiplying by its opposite, which is 2. Think of it like figuring out how many halves fit into a whole. If you have 125 whole apples in your basket and you want to know how many half apples you can make, you're simply cutting each of those 125 apples into 2 pieces.
And boom, there it is. 125 multiplied by 2 gives us 250. The grand answer to our first riddle completely revealed. See, the number didn't magically grow out of nowhere. We were simply counting smaller pieces, the halves, which naturally meant we ended up with way more of them. By using the fraction mirror, the trick is fully exposed. But what if the illusion gets a bit more complex? What if the decimals are a lot messier?
Well, there's an old adage in the realm of numbers that goes, to make the decimal vanish, we must shift the entire world together. And that hints at a second, incredibly powerful technique. Because sometimes, let's face it, converting to a fraction just isn't the fastest route. Sometimes you just want to clear the stage entirely and make those distracting decimal points disappear from view altogether.
Section 2. The Great Shifting Trick.
Now this is the ultimate technique used by mathematical illusionists to manipulate the board. Instead of fighting the decimal, we just change the scale of the entire environment so the decimal literally ceases to exist. Here's the secret. Treat the division problem exactly like a fraction, with a top number and a bottom number. As long as you multiply the top and the bottom by the exact same amount, say 10, 100, or 1,000, the balance of the riddle stays perfectly intact. You're effectively shifting the decimal points equally for both numbers. Just shift them enough times until both numbers become clean whole integers. Once those decimals are banished, you just divide normally.
Let's look at a really tricky illusion. 1.25 divided by 0.05. Looks awful, right? Way too many decimals. So let's apply the great shifting trick. We don't want to see decimals at all. We'll multiply both sides by 100. That means we shift the decimal point 2 places to the right for the first number, making it 125. And to maintain perfect balance, we also shift the decimal 2 places to the right for the second number, turning it into a clean 5. The reality behind the curtain is simply 125 divided by 5.
And the answer? A beautifully simple 25. The core value of the math didn't change for a second, only the presentation did. We literally shifted the world to suit our needs, completely removing all that visual clutter that made the original problem look so scary. This shifting trick is rock solid, and it works every single time to break the illusion.
Section 3. The Master's Secret. The Rule of Jumps.
But what if you're out wandering the realm, no pen or paper in sight, and you want to shatter these illusions entirely in your head? This is where we bypass the shifting trick completely. We have the base truth. 48 divided by 12 equals 4. That is an undeniable fact. But then the illusionist throws a giant smokescreen at you, 0.048 divided by 0.12. It looks terrifying. But underneath all those zeros and decimals, the base truth is completely intact. The answer absolutely must have something to do with the number 4. The only real mystery left is where the decimal point ultimately lands.
Think of the decimal places as opposing forces, basically pushing the final decimal point around. The first number in our riddle is 0.048. It has 3 decimal places. Because it's the starting number, it exerts a force pushing the final decimal point to the left. But the dividing number, the point 12, acts a bit differently. Division is the opposite of multiplication, right? So its 2 decimal places exert a force pushing the final decimal point back to the right.
So the real trick is just combining these forces. Step 1, we start at our base truth answer, which is 4.0. Step 2, the first number commands us to jump 3 spaces left. Step 3, but wait, the divider fights back and commands us to jump 2 spaces to the right. Step 4, we just calculate the net movement. If you go 3 steps left and then 2 steps back to the right, your total net movement is just 1 single space to the left.
And there is our elegantly simple solution, 0.4. We started at 4.0, took 1 net jump to the left, and landed precisely on the answer. We bypassed all the messy calculations, all the fractions, all the massive shifts. Just by tracking the directional jumps, the grand illusion is completely shattered in seconds.
Let's test this with one last, highly intimidating puzzle. The final riddle, 0.0018 divided by 0.02. To the untrained eye, this looks like pure madness. But to you, you see right through it now. The base truth is simply 18 divided by 2, which is 9. The first number pushes the decimal 4 jumps left. The dividing number pushes it 2 jumps right. The net movement? Exactly 2 jumps to the left. Start at 9.0, jump left twice, and you land elegantly on 0.09. You've completely mastered the fraction mirror, the great shifting trick, and the ultimate master's secret, the rule of jumps. The fog has officially lifted and the grand illusion of decimals has been entirely demystified. But I want to leave you with a provocative thought to end our explainer today. Now that you know how easily structural logic can dismantle what looks like magic, what other numerical riddles out there in the world are just waiting for you to see right through them? The realm of numbers is incredibly vast, and the illusions are many. But now, you've got the tools to reveal the truth. Keep questioning, keep looking past the smokescreens, and I'll see you in our next explainer.